You've probably imagined it as a switch. 1 second you're here, the next second, nothing. A flat line, a long beep, and that's it. The end of the story. But that is not what the data says. For the first time in history, doctors can put electrodes on a dying brain and actually watch what happens in the minutes after the heart stops. And what they're finding is stranger and somehow more alive than anything we expected. Because your brain does not switch off when you die. It fights back. And for a few minutes, it may be more active than it's ever been in your entire life. Let's start with the assumption doctors have held for decades. The textbook version goes like this. Your heart stops, blood stops reaching your brain, and within about 10 seconds you lose consciousness. Soon after, the brain is starved of oxygen and begins to shut down for good. Death, in this model, is a fade to black. In 2013, a neuroscientist at the University of Michigan named Jimo Borjigin decided to actually test that model. Her team wired up the brains of rats and induced cardiac arrest, then watched the electrical signal in real time. What she found broke the model completely. In the 30 seconds after the heart stopped, the rats' brains didn't go quiet, they lit up. A surge of gamma waves swept across the cortex, the same high-frequency signal linked to sharp focus, memory, and conscious awareness in a waking brain. And these weren't scattered, meaningless spikes. The different regions of the brain were talking to each other with more coordination than they had during normal waking life. The dying brain, for a few seconds, looked more awake than the living one. Nobody could explain why. The organ that was supposed to be shutting down was doing the opposite, throwing everything it had into one final burst before the signal went flat for good. For years, this was dismissed as a strange thing that only happened in rat brains under lab conditions. Then, in 2022, it happened in a human being by accident. Doctors in Canada were monitoring the brain of an 87-year-old man who was being treated for a head injury. He suffered a fatal heart attack in the middle of the recording. Nobody planned for this, but the equipment was already running and it captured something remarkable. In the seconds around his death, his brain produced the exact same kind of gamma wave surge seen in Borjigin's rats. The activity was concentrated in a region called the temporal parietal junction, a part of the brain linked to dreaming, memory recall, and out-of-body sensations. One accidental recording, but it lined up with a pattern doctors had been hearing about from survivors for years and had never been able to prove. Which brings us to the strangest study in this whole field. Between 2017 and 2020, a physician named Sam Parnia ran a study across 25 hospitals in the US and the UK. The study was called AWARE-2, and its goal was simple but audacious. Track brain activity during CPR in real cardiac arrest patients and see if any of them could later describe what happened while their heart was stopped. Of the 567 patients who went into cardiac arrest during the study, fewer than 1 in 10 survived long enough to be discharged from the hospital. Of the survivors interviewed afterward, about 1 in 5 described the lucid, structured experience of death, not a vague dream, but something they described as more real than ordinary consciousness. Some recalled a rapid, meaningful review of their own lives. Some described a sense of separating from their body and watching the resuscitation happen. And in one case, a patient accurately recalled a specific test, a word played through headphones during a period when their brain, by every conventional measure, should not have been able to process sound at all. For decades, doctors assumed the brain suffered irreversible damage in about 10 minutes of the heart stopping. Parnia's data suggested something different. In some patients, meaningful electrical activity, the kind linked to thought and memory, was returning to the brain even an hour into CPR. An hour, long after the moment doctors used to consider the point of no return. So here's the question none of this fully answers. Why would a dying brain do this? Why throw everything into one last surge instead of simply switching off? Nobody knows for certain, but there's a working theory, and it's a strange one. Under normal conditions, your brain spends enormous energy keeping itself in check, filtering out signals, suppressing certain circuits so you can function calmly in the world. Some researchers think that in the process of dying, as oxygen disappears, those inhibitory systems fail first. The brakes come off before the engine stops. For a brief window, Regions that are usually kept quiet are suddenly free to fire without restraints, all at once, in a burst of activity your waking mind never normally produces. If that theory holds, the vivid, hyper-real quality survivors describe, the sense that it felt more real than real life, isn't a hallucination bolted on top of dying. It might be what your brain actually looks like with the filters gone. This changes what the moment of death even means. We used to think of it as a single line you cross, 1 second alive, the next second nothing. The data increasingly suggests it's a process with its own internal event, its own final act, playing out over minutes we assumed were empty. And that reframes the question we started with. You pictured death as silence, a flat line and nothing else. But for a few minutes, in the dark, with the heart already stopped, your brain may be doing the loudest, most coordinated thing it has ever done. One last conversation with itself before the room finally goes quiet for good.